Space travel isn't just about reaching the stars. It has influenced countless innovations here on Earth, reshaping the way we live, communicate, and explore. Have you ever wondered how the advancements made for space missions impact our daily lives? What incredible technologies are helping us venture farther into the cosmos? Join us as we dive into 10 groundbreaking scientific innovations that are propelling us into the future of space travel and at the same time, transforming life on Earth. Stick with us to discover how space tech is changing the world beyond the stars. Reusable rockets, a revolution in space travel. One of the most profound innovations in space travel is the development of reusable rockets. Traditionally, each space launch involved the use of disposable rockets that would burn up or sink into the ocean, driving costs sky high. However, the concept of reusable rockets championed by SpaceX is changing this. Rockets like the Falcon 9 can land back on Earth, be refurbished, and reused in future launches. This has led to a significant reduction in costs, making space exploration more accessible to both public and private entities. Beyond the cost benefits, reusable rockets are accelerating the pace of space missions. For instance, SpaceX's frequent satellite launches, supported by this reusable technology, have made it possible to deploy large-scale projects like Starlink, a satellite network providing global internet access. Companies such as Blue Origin are also exploring this technology to advance human space tourism. As this technology becomes more refined, reusable rockets will likely become the backbone of long-duration missions to Mars and beyond. This innovation is not only democratizing access to space, but also marking a significant leap toward the colonization of other planets. Advanced propulsion systems, cutting travel time. One of the greatest obstacles to deep space exploration is the immense distances between planets, requiring years to traverse with current chemical propulsion systems. However, advancements in propulsion technology like ion drives and nuclear thermal propulsion are poised to change that. Ion thrusters, which use charged particles to create propulsion, are already in use for some spacecraft such as NASA's Dawn mission. These thrusters provide lower thrust but are far more fuel efficient, making them ideal for long-duration missions. On the other hand, nuclear thermal propulsion could offer even more significant breakthroughs. By using nuclear reactors to heat propellants, these engines promise to drastically reduce travel times to destinations like Mars. Studies suggest that nuclear propulsion could cut the travel time to Mars by more than half, reducing astronaut exposure to harmful space radiation. Additionally, these systems could support missions far beyond our solar system, making interstellar exploration a real possibility in the near future. Both ion and nuclear propulsion technologies represent the next frontier of space travel, addressing the critical need to cover vast distances in shorter periods. Artificial intelligence in space exploration. Artificial intelligence, AI, is already transforming space missions by automating tasks, analyzing large datasets, and aiding decision-making processes. For example, NASA's Mars rovers, such as Perseverance, use AI to autonomously navigate the Martian landscape, identify interesting geological features, and even decide which samples to collect for analysis. AI's ability to operate independently is crucial for missions where real-time communication with Earth is not feasible, such as those in deep space. Furthermore, AI algorithms are being used to process massive amounts of data collected by space telescopes and satellites. These AI systems help scientists identify patterns, detect anomalies, and even discover exoplanets. As AI technology continues to evolve, it will enable spacecraft to perform more complex tasks without human intervention. Future AI applications could include fully autonomous spacecraft capable of managing their systems, making decisions, and even repairing themselves mid-flight. This advancement will be essential for long-duration missions, such as crewed missions to Mars or beyond, where human control is limited by time delays in communication. 3D printing in space, a game-changer for construction. Space travel requires immense logistical planning, particularly when it comes to transporting materials. Enter 3D printing technology, a groundbreaking solution that allows astronauts to create essential components on site. NASA has already tested 3D printers aboard the International Space Station to produce tools and replacement parts, dramatically reducing the need to send costly resupply missions from Earth. This capability is especially crucial for longer missions to the Moon, Mars, or even beyond, where quick resupply from Earth is not feasible. What makes 3D printing even more exciting is its potential to create habitats using materials found on other planets. NASA and other space agencies are researching how to use lunar or Martian soil in 3D printing to build sustainable bases. This technology could also prove pivotal in building structures such as communication towers, landing pads, or even medical facilities on Mars. By manufacturing objects in space using local resources, 3D printing could cut mission costs and help establish the first human colonies on other celestial bodies. Spacesuit technology protecting astronauts in extreme environments. Spacesuits have evolved from the bulky, rigid designs of the Apollo era to modern, sleek, and technologically advanced garments. NASA's next-generation spacesuit, the Z2, offers improved mobility, better life support systems, and more advanced helmets with integrated heads-up displays. These upgrades will be crucial for astronauts on extended surface missions, such as NASA's planned Artemis missions to the Moon, where they will be conducting fieldwork for longer periods. In addition to mobility, spacesuits must protect astronauts from a range of environmental hazards, including temperature extremes, radiation, and micrometeoroids. The Z2 spacesuit has enhanced thermal regulation systems and radiation protection, making it suitable for both lunar and Martian missions. Furthermore, the suit's integrated heads-up display allows astronauts to access important information in real time, such as oxygen levels and navigation data, without needing to look away from their tasks. The continued evolution of spacesuit technology is key to ensuring that astronauts can work safely and efficiently in the most hostile environments. Satellite constellations enhancing global connectivity. Satellite constellations consisting of hundreds or thousands of small satellites working together in low Earth orbit are revolutionizing global connectivity. SpaceX's Starlink project, for example, is deploying thousands of satellites to create a network capable of delivering high-speed internet to even the most remote locations on Earth. This innovation has profound implications not just for connectivity, but also for space missions, as these constellations can provide more reliable communication and navigation support for spacecraft. In addition to boosting internet access, satellite constellations are improving Earth monitoring capabilities. They allow scientists to track environmental changes such as deforestation, climate change, and ocean pollution in near real time. These constellations are also being considered for use in space missions, where they could provide continuous communication and navigation support for future lunar and Martian missions. With companies like Amazon and OneWeb also entering the satellite game, the era of satellite constellations is just beginning. Habitat technologies for long-duration space missions. As space agencies plan manned missions to Mars and beyond, developing sustainable habitats for long-duration missions has become a priority. The challenge lies in creating self-sufficient living environments that can sustain astronauts for extended periods without resupply from Earth. One of the most exciting innovations is the development of inflatable habitats, which are lightweight, expandable, and capable of withstanding the harsh conditions of space. NASA has already tested these habitats on the ISS, with the Bigelow Expandable Activity Module, or BEAM, serving as a key experiment in demonstrating their viability. Inflatable habitats offer numerous advantages. They require less storage space during transport, and once inflated, they provide astronauts with significantly more room to live and work. These habitats are also designed to be highly durable, shielding astronauts from cosmic radiation and extreme temperatures. Researchers are exploring how to construct habitats on the Moon and Mars using local materials, such as regolith, the loose soil found on these celestial bodies. By utilizing three-dimensional printing technology and local resources, astronauts could build permanent bases without needing to bring vast quantities of building materials from Earth. In addition to housing, the technologies being developed for water recycling, food production, and waste management will make these habitats truly self-sufficient. Such systems are already in use on the ISS and will be refined for planetary bases, enabling future missions to the Moon, Mars, and beyond. As we push further into the solar system, these innovations will be critical to establishing a human presence on other planets. Health monitoring systems for astronauts. Astronauts face unique health challenges during space missions, from muscle atrophy and bone loss due to microgravity to exposure to cosmic radiation. Maintaining their health in such extreme environments requires cutting-edge health monitoring systems that provide real-time data on their physical and mental well-being. Wearable health sensors, developed by NASA and other space agencies, are being used to monitor an astronaut's vital signs, such as heart rate, oxygen levels, and sleep patterns. These systems send data to mission control, allowing for remote health management. Beyond tracking physical health, there is also a growing focus on mental health during long-duration missions. Extended periods in confined spaces and isolation from Earth can take a psychological toll. To address this, space agencies are developing mental health support systems that monitor stress levels and mood, ensuring astronauts can stay mentally fit during their missions. AI-driven systems are being tested to provide astronauts with personalized health recommendations based on real-time data, helping them adjust their exercise routines or diets to stay in peak condition. In the future, these innovations in health monitoring may have applications on Earth, particularly in remote locations or areas with limited access to healthcare. By providing real-time health data, these systems could revolutionize telemedicine, allowing doctors to monitor and treat patients from afar, improving outcomes for those in challenging environments. Space farming, growing food beyond Earth. One of the greatest challenges of long-term space exploration is sustaining astronauts with fresh food. Relying on pre-packaged meals is not a viable solution for missions lasting months or even years. That's where space farming comes in. NASA and other space agencies are developing innovative methods to grow crops in space using systems like hydroponics, growing plants without soil, and aeroponics, growing plants with air or mist. These systems are incredibly efficient, using minimal water in space, making them ideal for environments with limited resources. The veggie experiment aboard the ISS has already proven successful, with astronauts growing lettuce, radishes, and zinnias in space. These experiments are crucial in understanding how plants adapt to microgravity and determining what crops can be grown on the Moon or Mars. In the future, space farms could become the primary food source for astronauts on long-duration missions, providing fresh produce and a sense of normalcy in an otherwise isolated environment. As this technology matures, it could have profound implications for Earth as well. Vertical farming and other space-inspired agricultural techniques could help address food shortages and improve food security, especially in urban areas where space is limited. Space farming is not just about surviving in space. It's about finding sustainable solutions for life both on Earth and beyond. Water recycling systems, sustaining life in space. Water is perhaps the most critical resource for life, and in space, every drop counts. NASA has pioneered water recycling systems capable of turning sweat, urine, and even cabin humidity into drinkable water. The Environmental Control and Life Support System, or ECLSS, aboard the ISS recycles up to 90% of the water used, ensuring that astronauts have a reliable supply without needing constant resupply from Earth. This technology is essential for long-term missions, where transporting water would be prohibitively expensive. In the near future, these water recycling systems will be integral to missions to the Moon, Mars, and beyond. With limited access to water on these planets, recycling systems will ensure that astronauts can generate sufficient water for drinking, hygiene, and even crop cultivation in space farms. Engineers are also exploring in situ resource utilization, or ISRU, which involves extracting water from planetary sources like Martian ice or lunar soil. These advancements will enable space missions to be more self-sufficient, reducing the need for frequent and costly resupply missions from Earth. Beyond space travel, water recycling technologies have the potential to address water scarcity on Earth. As global populations grow and freshwater sources become more strained, advanced purification systems developed for space could be deployed in arid regions, providing clean drinking water to communities in need. Space innovations are not just shaping the future of exploration, they are offering solutions to some of Earth's most pressing challenges. As we've explored these fascinating innovations shaping the future of space travel, it's clear that space technology is not only about exploring distant planets, it's also about improving life on Earth. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.